This is from the Byte Go newsletter. Password, session, cookie, token, JWT-SSO, or of authentication explained. Part 2. Passwordless authentication. We have covered three types of authentication so far: HTTP basic authentication, session cookie authentication, and token-based authentication. They all require passwords. However, there are other ways to prove your identity without a password. When it comes to authentication, there are three factors to consider. One, the knowledge factors, something you know, such as a password. Two, ownership factor, something you own, such as a device or phone number. Three, inherence factor, something unique to you, such as your biometric features. So it's with you, with the physical being of yourself. Passwords fall under something you know. One-time password OTP prove that the user owns a cell phone or a device, while biometric authentication proves something unique to you. One-time passwords (OTP). One-time passwords (OTP) are widely used as a more secure method of authentication. Unlike static passwords, which can be reused, OTPs are valid for a limited time, typically a few minutes. This means that even if someone intercepts an OTP, they can't use it to log in later. Additionally, OTP requires something you own, as well as something you know to log in. This can be a cell phone number or email address that the user has access to, making it harder for hackers to steal. However, it's important to note that using SMS as the delivery method for OTP can be less secure than other methods. This is because SMS messages can be intercepted or redirected by hackers, particularly if the user's phone number has been compromised. In some cases, attackers have been able to hijack phone numbers by convincing the mobile carrier to transfer the number to a new SIM card. Once the attacker has control of the number, they can intercept any OTP sent with SMS. For this reason, it's recommended to use alternative delivery methods such as email or mobile apps whenever possible. Here's how OTP work in some detail. Step 1. The user wants to log into a website and is asked to enter username, cell phone number, or email. Step 2. The server generates an OTP with an expiration time. Step 3. The server sends the OTP to the user's device via SMS or email. Step 4. The user enters the OTP received in the login box. Step 5 and 6. The server compares the generated OTP with the one the user has entered. If they match, login is granted. Yeah, so we see here the steps. The user logs in, he receives an OTP, he enters the OTP, and the OTP is then compared. Alternatively, a hardware or software key can be used to generate OTPs or multi-factor authentication (MFA). For example, Google 2FA uses a software key that generates a new OTP every 30 seconds. When logging in, users enter their password and the current OTP displayed on their device. This adds an extra layer of security as hackers would need to access the user's device to steal the OTP. SSO Single Sign-On. SSO Single Sign-On is a user authentication method that allows us to access multiple systems or applications with a single set of credentials. SSO streamlines the login process, providing a seamless user experience across various platforms. The SSO process mainly relies on a central authentication service, CAS server. Here's a step-by-step breakdown of the SSO process. When we attempt to log in into applications such as Gmail, we're directed to the CAS server. The CAS server verifies our login credentials and creates a ticket granting ticket, TGT. This TGT is then stored in a ticket granting cookie on our browser, representing our global session. CAS generates a service ticket for our visit to Gmail and redirects back to Gmail with the ST. Gmail uses the ST to validate our login with the CAS server. After validation, we can access Gmail. When we want to access another application like YouTube, the process is simplified since we already have a TGC from our Gmail login. That was not that clear, right? when we attempt to log in an application as Gmail, we are redirected to a CAS. Okay, so first there is a redirection to a CAS server. The CAS server verifies our login, so this is the service that verifies our login and creates a TGT, some ticket, stores on our cookie. The CAS generates another ticket for the Gmail. To Gmail, and Gmail uses ST to validate, so Gmail compares both tickets and validates that we are there. This process reduces the need to remember enter multiple sets of credentials different applications. There are different protocols that facilitate SSO. SAML, Security Assertion Markup Language, is widely used in enterprise applications. SAML communicates authentication and authorization in XML format. OIDC, OpenID Connect, is popular in consumer applications. OIDC handles authentication through JSON Web Tokens and builds on the OAuth2 framework. More on this on the next session. For new application, OIDC is the preferred choice. It supports various client types, including web-based, mobile, and JavaScript clients. SSO offers streamlined and secure authentication method, providing a seamless user experience by requiring only one set of credentials for multiple applications. This approach enhances security through the use of strong, unique passwords and reduces phishing risk. It also minimizes the administrative burden IT departments. OAuth2 and OpenID. This topic is so boring. It's so important, but it's also so boring. How could we make this more interesting, this topic, right? I mean, it's so boring. Okay, let's continue. OAuth2 and the OpenID Connect. While OAuth2 is primarily an authorization framework, it can be used in conjunction with OpenID Connect or IDC to authentication process. OIDC is on the authentication layer on top of OAuth2, enabling the verification of user identity and granting controlled access. I think that the one way to make this topic much clearer, much more interesting, is if we had a home extension. Maybe there is one. Maybe there is one that would show the whole process while we do it on a daily basis. It will tell you are now on SAML, you are now on IDC, and we are generating the ticket. The ticket is transferred to here. It could make things more interesting. When using sign-in with Google or similar features too, and OIDC work together to streamline the authentication process. OIDC provides user identity data in the form of standardized JSON Web Tokens, JWT. This token contains information about the authentication user, the authenticated user, allowing the third-party application to create a user profile. So the process repeats. I mean, every time we do some login, they generate some ticket, they provide a ticket to the other system, we store some part of the ticket in our cookie, then the other server compares the two tickets. In this setup, OAuth2 provides secure delegated access by issuing short-lived tokens instead of passwords, allowing third-party services to access protected resources with the resources owner permission. This method enhances security as the third-party service does not handle or store the user password directly. Let's see the diagram. Client, authorization request, resource owner, authorization granted, authorization grant to the authorization server, brings back access token to the resource server. In the sign-in with Google example, OAuth2 defines two roles: resource owner, the end user who controls access to their personal data; resource server, the Google server hosting the user profiles as protected resources. It uses access tokens to respond to protected resources requests, ensuring that only authorized services can access the data. Three clients: the device, PC or smartphone, making request on behalf of the resource owner. This device represents the third-party application seeking access. Authorization server, the Google authorization server. I mean, we see the same players again. The client that wants access, the resource owner, the resource server, the authentication server. OAuth2 offers four types of authorization grants to accommodate different situations. One, authorization code grant, the most complete and versatile mode, most suitable for application types. More details below. Implicit grant, it's so boring. Designed for applications with only a front end, such as single page applications or mobile apps. Resource owner, resource credentials. God. Okay, so this was it, I guess. The authorization code grant is one example worth examining. The specification is this RFC. Again, we have some user agent, some client calling some user agent, asking resource owner to access. Resource owner says, I need authentication. The user agent going back to the client. Then the client is saying to the authorization server, yes, please give me authorization, gives him back a token, gives back the token to the user agent. This was it. Byte goes newsletter. It's very good. I just think that specifically this topic is not that interesting, but it's good to know.